So welcome to day 7. This is Alok and for day 7 we have got a very interesting topic and a very important one obviously is SSH. So we are going to learn what is SSH server, why we will be using SSH, what are the advantages of using SSH. So SSH is one of the ways in which you can access the shell of a remote machine. Let's presume I am sitting on server 1 and I want to do some job on server 3. This is my server 3. So how will I do it? It's having a different background. So one way is that though it is here, it is like I have got the physical access on the server 3, but might be it's a different machine at some remote location. So how I am going to access it? So there are a couple of ways in which you can access the shell or the command line of a remote machine. Like you have got telnet, RSH. There are a lot of methods. So in the early days, we used to use telnet as a method of hitting the remote machine and executing certain job. So telnet was the option, rlogin was the option, and RSH was the option. But the problem with the telnet was that it transfers everything in plain text. So whatever you are doing, it's transferring it in the plain text. So that makes it very dangerous because you might be executing certain important commands. You might be creating some user accounts with the passwords on the remote servers. And presume if someone is sniffing it and he is getting everything in the plain text. So this is a security issue. And it's very dangerous. So let me just show you this. Let's make it more practical. So if I go to server 3 and I install here telnet server, let me just try to show you what exactly I'm saying. So I have installed the telnet server. So once the package is installed, I need to start the service. You know this, we had been doing this. Systemctl start telnet socket, and if I check it, systemctl status, it's running. So telnet is listening here, running here. So this is a remote machine and I am sitting on say server 1 and I want to use the telnet to access the remote machine which is server 3. So I should have the telnet client installed. So remember, on the server I had installed the telnet server, the telnet server, and on the client which is supposed to hit it, I should be installing the telnet, the client side. I had installed the telnet client side here as it is again a client server architecture, and I give a telnet and the IP address of the remote machine. So the IP is 192.168.0.210. So I can give 192.168.0.210, but I don't know that someone might be sniffing the data what I'm doing. So someone might have installed TCP dump. So TCP dump package is used to sniff your packets and can be used to analyze it. By default it is installed during the time of the installation. So I can confirm it. If I do a TCP dump, it's @anaconda. That means @anaconda means it is being installed at the time of the installation. So I can use, and my interface is this interface. So I'll just copy this because whatever communication I'll be doing from server 1, server 3 will be receiving it on this interface. So I copy this. I'm going to show you the vulnerability or the issues with the telnet. Now I start capturing the packet using the TCP dump. I create a file here, capture.pcap, name can be anything, and the interface is this. It's listening here. I go here now, I do a telnet, I give Alok as the password and Red Hat as the password. Sorry. Now if you see here, from server 1 I am on server 3, so it is as good as I am sitting on that server. So and now I execute certain commands like df-h. I'm executing certain very important tasks. I'm trying to see some file here, say etc host. I'm trying to see some file. Let me give a tab here and see. Say, okay, let's check what is in this storage.log. Okay, it's a blank file, but I am doing certain things, right? And then I had terminated my session once the job is done. So I here press Control C. So you can see it has captured these packets, and the packets are being stored in a file capture.pcap or whatever name you had given here. Now I will show you how to read it. So we use the TCP dump once again. So I use like certain options which will help you to read it in a very clear method. So this is 0 here. So see here, this is plain text. I will show you. Everything is captured in the plain text here. See Alok at server 3. Scroll up a bit. This is the command that I had given, if you remember, cat tmp and storage. So the whole output is there. So that means I should have the output of the df-h also somewhere. Let's go up. This is my etc host. Wow. So it's being captured. Everything is being captured by TCP dump, and the telnet is transferring everything in the plain text so anyone can read it. Let's move further up. Here it is. Oh, see the df-h output, which is very dangerous. I don't want this. That's why the telnet is no longer in use. So the issue was that it was transferring everything in the plain text. So here comes SSH. So SSH is used to transfer to access the remote machine, to manage the remote server, and one of the benefit is that it transmit everything in an encrypted manner. And SSH is actually originally not like originally, it was created in 1995 by a person named Tatuyonan, Tatuylon in 1995. So that's a small history. So telnet is created to give best security whenever accessing the remote machines. So it gives me encryption, it gives me secure file transfer, it gives me facilities like X11 forwarding, it gives me facilities like port forwarding. So if I repeat the same thing with SSH, so everything should be encrypted, right? So let's first see it, and then I will show you the files and the configuration things. So again I am capturing it. Now instead of telnet I will use SSH. So I use here, I just replace it with SSH, root @ So when you SSH a machine for the first time, when you do it for the first time, so what happens? The key, the initial key, the identity of the machine, a fingerprint is being added in the machine which is hitting it. So server 1 is the client in this case, and server 3 is the server. So you need to accept these keys, and obviously you need to have the access. So I have the access. So now I am on server 3, and if I give the same command, so df-h, I give cat temp storage.log, and then I exit. Let's see what it has captured. I do press a Control C here, and this is a file capture.pcap. Then repeat the same command. That's it. See here, you won't be able to see a single character. Everything will be encrypted. No df-h output, no cat output, nothing. So that makes it's all encrypted. That makes it very secure to manage the remote machines in a safe and a secure manner. And SSH has got two ways of a kind of the working mechanism in which it can work. You can have a key based authentication as well as a password based authentication. So if you see here right now, I had done the password based authentication. The machine will prompt me for the password. It's not asking me that fingerprint. Why? Because once you had accepted that fingerprint here, once I had accepted that fingerprint here by giving the yes here, that machine identity is stored in my home directory under a folder .ssh, which will be automatically created in a file known host. So SSH don't rely on the IP. It matches the IP of the machine with this fingerprint. This is the identity of this machine from the perspective of SSH. So this IP should match this fingerprint. If it matches, then only you are hitting the same machine. Otherwise, you might be a victim of IP spoofing. I can try to show you this. This IP is 210. So 210 is of server 3. Okay. So what I do here, I try to shut down this machine. I just try to do a shutdown here. 210. I shut it down. Now I go to server 2. I have got one more machine. I give it's with a pinkish background. I change its IP. So I change it to it's 200 currently. Let me try to change it to 210. So someone has changed the IP address of the machine. It's 210 now. So will I am sitting on server 1, will I be able to know that someone remotely had shut down the server 3 and is spoofing the IP the same and is faking the same IP address on a fake machine? It's a fake machine, because first of all I will try to do a ping to see whether that server is live or not. It's pinging. That's great. Now if I do a SSH, if you remember earlier, the fingerprints were of this machine which someone has shut it down. If I press enter here, you will be getting this warning that remote host identification has changed. It is possible that someone is doing something nasty. You might be a victim of man in the middle attack. That means what? I am hitting on the IP. Yes, perfect. But the fingerprint of this fake machine is different from the fingerprint which is stored with respect to the same IP in my machine. So your machine specifically gives you a warning. This is not the same machine you have accessed earlier. So this again, this facility was not at all there with Telnet. So if anyone would have spoofed the IP, you might end up copying certain important files on a fake machine, but SSH won't allow this. It won't trust the IP address, as IP address is a software address and it can be changed any number of times in a day. So if I revert it, I make it 200 once again, apply this, switch it on, switch it off, it's 200, and I turn this machine on once again, I should not be getting the same warning, because the same machine with a fingerprint with the same identity. So consider the fingerprints as your fingerprints. No one can spoof your fingerprints. So this is one of the methods used by SSH to avoid man in the middle attack and to avoid IP spoofing, which is not there in Telnet. And apart from what I had shown you, that it transfers everything in the encrypted manner. A tunnel is being created. So this is the password based authentication, the normal way. Just a moment, let it come. Yeah. So this machine is up once again. Okay, let me check the connectivity. Just connect it. Let's check it out. So the 210 IP is given to it. That's great. The same IP that we wanted. 210. So if I hit it again, it's what? It's working. Red hat. So if someone tries to spoof or change the IP or fake the IP on a fake machine remotely, SSH will stop you there only. And it clearly tells you that this is the file which is giving you this message. And in case someone has genuinely removed the machine because there might be some hardware issues, then you need to remove this file to get rid of this message. That you have to do it. And SSH encryption, SSH is very kind of flexible. SSH can use various forms of encryption, right from 512 bits to 32768 bits, and it can include ciphers like AES, triple DES, blowfish, cast 128 and arc4. It can use any of these ciphers. But you should remember one thing: the higher the bits, the longer it will take to generate and use those keys, and the longer it will take to transfer the data. So you have to take care that the number of bits, the encryption that you want to use, is actually inversely proportional to the speed. So you have to take care of that thing. Now, so we had learned about the major files, the known host file. As I have shown you, I can do an exit here. And once you are doing a SSH, you can give very simple commands like w command and the login command, which will show you that someone is doing SSH from the IP 100, and the information will always be available under var log secure accepted root password from this port. So you should be aware of these things. So SSH host keys, you are aware of the host keys, that under your home directory there will be a folder SSH, sorry, not here, there will be a folder SSH, and inside SSH there will be the file known host, which will be containing the host keys. The host IDs, actually not keys, host IDs are stored in this file, and whereas my host keys are stored under /SSH, and these are the keys. This is my key, SSH underscore host underscore RSA EDSA. These are my keys, my identity. So normally you can use password based authentication, which I am using. That, like, if I give, so it prompts me for the password, I supply the password, and I am right there on server 3, which is good. But normally you should not be using the password based authentication. You should be using key based authentication. So let's understand why key based authentication is much more secure than a password based authentication. So it's a time to understand why the key based authentication is much more secure than the password based authentication. So what happens? The password based authentications are also secure. I'm not at all saying they are not secure. The client can normally use the password, or they can use SSH keys. So password logins are encrypted, there is no doubt about that, and it's very easy to understand for a newbie, like we are doing it for the first time. So you can easily, like, understood, fine, I should be knowing the password of the root of server 3. Then when I hit it, it prompts me for the password, which is very obvious. I supply the password and I am on server 3. But but it's slightly more vulnerable to automated bots, which might try repeatedly to authenticate using the passwords, and they might succeed. So that's why on production servers, we generally, you will see the key based authentication. And in this case, in password based authentication, if root of server 3 has changed his password, he need to update the root of server 1 that my password is changed, and he might not be interested in sharing his password because of social engineering issues, because everyone has got a specific kind of pattern of giving the passwords. You might be giving the password on movie names, your girlfriend names, your boyfriend names, whatever. So how can I use keybase? Because I don't want to share my password and I want it more secure. I want the security from automated bots. I don't want that. So there is only two steps involved. It's very simple. First step is you need to generate your keys. So the server 1 will generate his identity, SSH identity, and then he will be sharing or sending his identity to server 3. Now it is on discretion of server 3 whether he want to accept it or not. Like suppose, I'll give you a very simple example. You have sent me a Facebook friend request. That's fine because you have your identity on the Facebook. So I can generate my identity by the command ssh key gen. So first step is in the key based authentication that you should be generating your machine keys. So it goes under your home directory .ssh id underscore rsa. Please never ever share this file to anyone. This is your private key. Do not share it with anyone. I just press enter here. Just ignore the passphrase right now. Enter. Your keys are created and it goes under your .ssh. This is the key. id underscore rsa is your private key and id underscore rsa .pub is your public key. Now I need to send this key id underscore rsa.pub, not the private key, never, to the remote machine, to this machine. So either you can email it and attach this file or send it in any way, use SCP. So there is a command here, ssh copy id, which will automatically does the job for you. So I give a ssh copy id and root @ the remote machine which I intend to share, 210. Obviously, for the first time, I'll be prompted for the root password of 210. I give Red Hat. Job done. So if I go to the Red Hat, your server 3 under .ssh folder, you will find a file authorized underscore keys, which is automatically created by the ssh copy id command, and my keys are stored here. This is my identity. This is my identity which is accepted by the server 3. See here, server1.networknuts.net. So now what? Now what? He has accepted me as a friend. Trust me. So now if I give ssh root @ 192.168.0.210, you will see without password. I am on server 3 without password. So this is what we call it a key based authentication, and you are identified by your key. There are certain very interesting things that you can do, because when I do it, I got the shell of server 3. I can do anything. So certain things which are not there in your courseware of RSC, I would like to explain it to you. You can restrict the client to execute only certain commands. Say server 3 admin, because he knows that I have accepted server 1 key, so he can do anything. He don't want this. Say the job of the server 1 is to go to the server 3 and run a small application, say top command. Say, so what he will do, because if right now he can get the shell and now he can execute the top command, fair enough, but he can execute any other command also. Any other command, fdisk-l, anything. I don't want that. I want that he should be allowed. Fine, I had accepted your keys, but you should have restricted access. So I can put a command also that you should be running only this command. So either there are a couple of ways. I can give the command from here itself. Say I can give anything. Say cal. See, I am on server 1, but the cal is executed on that machine 210. So you can specify the command also. So I can execute certain other things. The df-h output to temp disk free.txt. See, another example. Job done. So if I go to server 3, if I go to temp, you will see disk free.txt is created, which obviously will be containing the output of the df-h. So in this manner, you can directly execute a command without getting on the shell. The other way might be was that first you go get the shell and then you give df-h like this. So which is again good, but if you intend to just execute a certain command, so you can go ahead with this method. Instead of doing this, just straight away give the command on the command line. So that is possible. You can also say try to run an application here. See here, I know that this file is being created, disk free.txt is being created. Now see here, I want to open this file. So if I give a vim of temp disk free.txt, it's not coming. Okay, see here, it's not at all what I had expected. So in this, because the terminal was not allocated to it, so you can try giving it with -t. See, this is proper. So if you want to open a terminal application, you can use -t and then open any file here. It's proper vim working with -t. If you can read it, man ssh or -f1 help, you can see there t. You can check for the T option here, or can give man ssh. You can read a lot about it, what I'm doing. qrst T, sudo terminal allocation. Right. I can, but so one method is this, that instead of going into the shell and then executing the command, straight away give the command from here, which will work. But because my keys are shared, the server 210 has accepted my keys. That doesn't mean he can't stop me. He can stop me. Say I give a very simple command where is top. So top is under usr bin top. See here, I copy this, I go to my ssh folder. This is the identity of the server 1. So here I give write command equal to paste it. Now see what happened. I had put one command here in front of the key. So see what will happen now. It is on discretion of the server 3, the remote server, what he wanted server 1 to do. So if I give this command now, I won't be getting shell. That application will directly be executed, and when I quit, I will be coming back on my server 1. Server 3 is not giving me the shell. And if I try to execute this command, see this, I cannot do it now. So I am allowed to go to server 1, is allowed to go to server 3, but server 3 has restricted him with this command only. He will be allowed to execute only this command. There are certain other parameters which I really like, that you can specify the source also, which IPs are allowed. So I can specify here, say 192.168.0. all the one. So I can specify here anything like this, and then comma, then command. So only this machine is allowed only when the IP is this. You can have X11 forwarding also. What is X11 forwarding? So I'm not going to execute this. I'll just show it to you. This, if it is done, I'm just going to remove this because I have to show you a couple of things. Now, once I have removed that command option, now I'm getting the shell. Can I run Firefox or any application? No. Why not? Because the X11 forwarding is by default not enabled. So if you want to run any GUI application which is available on server 3 and you want to run it now, you have to use the SSH with X11 forwarding. Just write -X. See now. Or any other application. It might not be working. And now I give Firefox. Now it's working. Now it's working. So we call it X11 forwarding when you intend to run any graphical application. So please, you need to do a SSH with -X. That means X11 forwarding. So by default, X11 forwarding is not allowed, but you can specify it that I want X11 forwarding. There are, so let's understand what are the major files. So in SSH, this is the main directory, and these are the two files: ssh_config, which is the client side file, and sshd_config daemon, which is the server side file. So there are a lot of things that you can configure in sshd_config. Say you can change the port if you wish. You can allow a certain user, deny a certain user. I'll show you certain things. Say permit root login is by default yes. You don't want to do a root login. That means you should be going in with Alok or any other user, then doing a SU. See here, switch user. So I say permit root login no, and obviously I need to restart the SSHD. Now if I go here, I do a root here, I'm giving the right password, Red Hat. It won't accept. Red Hat, it won't accept. Sorry, Red Hat, it won't accept because the root login is not allowed. So I can, how will I move now? I have to log in with a normal user, then I can do a SU, which is permissible. So you can configure a lot of restrictions there. I can have a banner file also, which will give me the banner. If I search here, like see here, there's a banners option. You want to throw certain message, or you can say allow users root, and you say deny users allow. I can do it like this also. So I had explicitly denied the alloc now. So again I need to restart the SSHD. Now if I go back once again and try to do alloc, it's not allowed. Believe me, I'm giving the right password. Red Hat. But now if I repeat it with or change it to root, it's done without the password because the keys are already shared. And guys, remember one thing, all the SSH activity will be logged under var log secure. See here, failed login, failed login, failed login, failed login, successful login. So if you want to know how many times someone has tried to do a SSH failed or successful, you can try this. Last command will also work, and last B will also work for bad logins. Last B, bad logins, will show you that from this IP address someone is trying to log in with Alok using SSH. Last B, bad logins. And last command will show you the successful logins. So these are the IPs from where someone has successfully logged in. Can you see it? Yes, you can see it. So you can have all those things here. So at least by the end of the day 7, you should have a clear understanding of what SSH does, what are the benefits of SSH over Telnet and other protocols like RSH and RLogin. And I had shown you with the TCP dump that it transfers everything in the plain text, the Telnet, whereas the SSH transmits everything in the encrypted manner. So you should have a clear understanding of these things. Let me show you the banner also. You can specify the banner here. So if I open the sshd underscore config, and remember, any point of time, please feel free to use man sshd underscore config. See here, allow users, deny users, everything will be there. Banner, deny users. So let me just give a banner for you. So anywhere here I write banner and say I give the file etc motd. Now I will create this file etc and write here any stuff, say welcome to secure server, say virtual welcome to Adobe of RSCE, any message, you are accessing a secure server, anything, save and come out, restart the service. Now let's see what will happen. If I do a exit from here and do a login once again, you will get this message. Welcome to Adobe RSCE, you are accessing a secure server. So you can try to make it more secure, more interactive. So you should have a clear understanding of SSH by the end of the day 7. And in next class, we will be learning about the logs. What are the logs? The important log locations. We will be learning about general CTL. Very interesting stuff. So then I'll see you again tomorrow. Till then, just do this, do the labs. Take care. Bye bye. God bless.